Hello there. How are we? So, been pottering about, having a wee think about some stuff as always, and you know, I'm continually having these thoughts and contemplating what's actually going on and asking these questions. So, you know, basically, you know, this is just always about questioning, asking questions to see what we get. And anybody that's been involved, as I say, there's really no much discussion to be had in regards to the Earth's dimensions. It's over with as far as I'm concerned. So there's other questions I've got in regards to reality, how it functions. In particular, I'm back at this again, as I've said before, I'm not going to shy away based on propaganda and fear tactics and whatever else. My questions are, you know, relevant to the topic. You know, we have direction. We have weight. What dictates these things? So I'm going to go back over these things again, mainly for myself and hopefully for other people who may still be stuck. I still see a lot of people, you know, talking about, you know, downward forces, density, relative density, and all this stuff. And it doesn't mean anything. And I'll go through why it doesn't mean anything, and why it is not a dictator of direction or weight or any of these things, just saying density, density, density. People really need to break beyond the propaganda and not be scared to investigate and go where reality is showing you. And as I say, it's something that has gripped me. And like many of you probably, you're curious, and you should be curious and asking questions about your reality and how it functions. And as I say, going through methodically your own understanding and applying questions that you have to reality, and what reality has to offer you and show you, you know. So, as I said, look, I'm not here to entertain anybody. If you've heard this before and it's no entertaining for you, I suggest that you just toddle off right now, because I'm going to continually put these questions up here. And for me, I feel there's a lot of gatekeeping going on in regards to this avenue or this particular question. So many contradictions and things that just don't make any sense in regards to the globular model. So we'll be having a wee look at how the globular model lays out force, direction, weight, upward forces and all this kind of stuff. As I say, I'm not going to be on that long this evening. It's just on my mind, and when it's on my mind, I'm just going to start putting this on. Rather than sit here playing the guitar, having the thoughts going round and round, I'm just going to lay it out and put it out there. As I say, I'm always open to have the discussions. You know, I've had people coming before, there's other people who are looking and investigating. I know Good Times for All was looking at electric potential and maybe that being something that denotes direction and whatever else, but I'm not seeing anything in regards to that yet. As I say, I'm open to the possibility, but right now motion for me is what dictates, you know, our direction. Without motion, you're not going to have experience in the first place. We experience life in motion. If there was no motion, you wouldn't be having an experience. So for me, the fundamental baseline of this experience is that everything is in motion. So we need to look at that in regards to where we get weight and where we get our direction. That's where it takes me. And as I say, I'm not going to shy away, and neither should you. How are we all? I see, I feel there is a lot of gatekeeping going on. Nobody talks about this. It's all just left there. Everybody's focusing on horizons, visible phenomena, optical phenomena, debates. As I say, the Earth's not a sphere, the Earth's a plane. Right? That's just a fact. And if you're somebody new, then, you know, I can help you, but not right now. I'm not going to be discussing the proofsies and the arguments for and against, you know, the false dichotomy of globe versus flat Earth. Okay? Specifically here, I'm talking about what dictates our direction of down. Hello, people. How are we? There is no debate. It is fascinating, Jacques. As I say, people don't go to the places that they should, because the majority of people, when they come across something like flat Earth, they immediately are met by the Flat Earth Society and propaganda surrounding it. In particular, the Earth moving in uniform motion and how fucking ridiculous it is and all this stuff. So immediately people buy into that because it's been presented to them, it's a laughing stock, and then they move on, and then they're met with questions. They're looking at gravity, they're looking at these things, and they don't know how to destroy it. And anybody that comes to this channel knows that gravity and its function, or supposed function, has been obliterated by the use of the term pulling force. We'll have a wee look at that in a wee minute. Right? Now again, these are things that people can understand for themselves, and if you're looking at characters online and YouTubes or wherever else, they will never bring these things up. Right? And then they'll point the finger and name call at somebody like me who tries to bring it into the discussion. Because again, it's important to me. I really am an honest person, a real, genuine, common man who wants to know exactly where the fuck I am. I'm not here to please anybody, be accepted by anybody, or any of that fucking stuff. Ask questions. It's an investigation. You and everybody else are the scientists. We are the explorers. So we have to ask these questions together and see what we can come up with. Again, I'm open to anybody's postulations, you know, demonstrations of practical reference for whatever they suggest they think is going on. Who's here? How are we? Paul E, bloody sticker in water. Don't underestimate Lobo. Whatever. TP in a tree. Martin Allen. Baron Bronskevich. Kiara McGrath. How you do? Rickus Vaticus. How you doing, bud? Tony Dixon. Oops. Shit, where was I? Mason B. So it would be nice, anybody can join me this evening if you want to join me. Also in the chat box, I would like some feedback. Anybody else that's got questions, queries surrounding this particular question. That's it, Tony Dixon. So, anyhow. So what do we need to look at? People know that they talk about forces, right? So they talk about gravity as being some sort of weak force. Firstly, we need to understand what we mean by force. Force is something that will cause something else to move, okay, unless it's opposed in some way by various different means, mainly friction. So force really is about making something move. As I've demonstrated so many times and had it out here, to make something move, when we talk about making things move, we need some sort of pressure applied or pressure taken away. That is the facts of your reality. Something must press on something else, pressing against it in order to make it move. Okay? Let me just finish this and then we'll go a wee look at it, some of it. We'll look at what the, as I say, the mainstream kind of globular understanding and thinking is, although it's obscure and fucking retarded. But we need to get through it. Aye, that's the thing, Jacqua. You know, an equilateral triangle of drones or whatever. You know, if something's going to be disappearing in front of you, you know, over a curve, then an observer at, you know, a tangent to both you and the object, you know, at 60 degrees or whatever from both you and the object, should see a decrease from the central point from left to right. Just like when they show you the nonsense ISS, you see this fucking thing. It's always the same, Pete. Whatever tattoos and all that stuff, great. And I say, you know, this is the nonsense that you get, fucking tattoos and whatever else, anything other than, you know, focus on the actual content, what's being discussed. So, as I said, if you've heard it before, it's time for you to go somewhere else, because you're not going to be impressed if you've heard it before. Anyway, I'm going to continue to keep bringing it, because I don't see many people bring it to the forefront. I say gravity and its function as a central hub, the central hub for the whole nonsensical, you know, storyline that is our existence, that being the heliocentric Big Bang globular Earth spinny space testicle cosmology. So I'll just use these wee videos rather than me. You know, I'm going to utilise the whiteboard because I'm a scientist, and scientists use whiteboards. These are just easier for us to get into it. So,
the bicycle. We hear the usage of this term many times in our day-to-day life. We might not know that we're using it. Opening a door, riding a bicycle, lifting an object are few of the most common things that we perform in our daily lives, and all these require a force. What is a force? Consider a ball lying on the ground at rest. It's not moving. Suppose this player here wants to pass this ball to his teammate who is standing on the other side of the pitch. How will he do?
So this is just to sum this up for you, because this is not the video I wanted. But a force is just making something move. Okay, so in this case they're going to press against this side of the ball and move it towards this person. So there's an applied pressure here, you know, and it's going to move in that direction. Now, if the ball was here and this person wanted to bring the ball back to them, they would have to place their foot over the other side of the ball and bring it towards themselves, which you would describe as pull. But the mechanical function, the interaction, is pressure here or pressure here. Okay? Pull is only a descriptor for direction, i.e. bringing something closer towards yourself. That's not what we're talking about here. We're talking about the mechanical interaction of what is necessary in order to achieve the motion of that object. In any given case, motion requires force. Force is pressure. Something pressing on something else. So this is the one.
Correct. It hardly explains anything about...
See, this again, just to highlight it for people, the use of the language when they talk about force and it's a push or a pull upon an object. For me, this is deliberate and it's part of the sophistry, omitting certain aspects because it gives the impression, particularly to vulnerable children and people who are easily swayed, that there's two different things at play when we talk about push and pull. The two different things, as I've described, is either pushing something further away, or when you say pull, you're bringing something closer to. Now, in both cases, it is the same thing that is applied in order to achieve the motion. So there's no two things going on. Force is pressure.
The concept of force. This is what you will assume after reading this definition. You will imagine a stationary object on the ground and someone pushing it or pulling it. Yes, when force is applied, the stationary object will move. But just this does not explain the concept of force entirely. Before we move on to the definition of force, let's clear a few misconceptions about it.
Aye, let's.
Let me ask you a question. This ball is lying at rest on the ground. It's stationary, not moving at all. Is there any force acting on it? Listen to my question carefully. Are there any forces acting on the ball when it is stationary?
I'll pause it there for anybody that's not seen this and let you think. Time's up.
If your answer was a no, or if you didn't have an answer, it means you don't know the concept of force yet. The answer is yes. There are forces acting on this ball. There is a gravitational force which is trying to pull the ball towards.
And now we get to the sophistry. A gravitational force. And remember, they utilise this terminology continually. Right? So again, they're trying to assert that this under here somehow can have an effect on this. Although, as I stated to you, if you have a person here, they apply a pressure here to make it go further away, or they need to bring their foot over the other side of the ball to bring it towards them. Both cases, for motion to be achieved, is pressure. Okay? You cannot make one object go in any direction without something applying a pressure somewhere. Now, how do you apply a pressure to something if you're beneath the something? How do you then apply a pressure to make that object move towards you? You either need to attach yourself to it, therefore it becomes an extension of you, or you have to place something on the opposite side to apply the pressure here in order to bring it towards you. There is nothing ever going to happen without that taking place. But again, they need to utilise the language. They must have imaginary, magical concepts of motion being achieved in order to maintain their religious, philosophical, idiotic worldview of nonsense physics.
It's the centre of the earth. And the ground is applying an equal force exactly in the opposite direction.
Exactly. So here, listen to this. Because how they use equal and opposite, right? They've just inverted it.
This force is called the normal force.
The normal force, which is the ground pushing upon the object.
Because these two forces are balanced, they do not change the position of an object. The net force acting on the ball is zero. So what does this tell you? Just humans pushing or pulling is not the only kind of force. And just because there are forces acting on
the only kind of force in regards to motion is applied pressure.
Object will not mean the object will move. For the object to move, there has to be some net force. So now let's say a person softly kicks the ball. What happens then? Yes, the position of the ball changes. Why did the position change? It's because there was another magnitude of force acting on it, and this time the forces were not balanced. The ball...
When it says push, it's just pressure. There's an impact, there's a pressure happening upon the surface of that. Okay? That overcomes what is beneath.
Moved and there was displacement. But hold on. Why did the ball stop moving after covering 15 meters? The ball started moving at a pace and then slowly came to a halt. If there's no force from the other side to stop it, how did it stop? Was there a force which stopped it? Yes, it was friction that stopped the ball. While the force you applied was towards the right, the force of friction was towards the left. Let's make it even more interesting. Assume your screen to be a frame of reference in this example. Also assume that this straight horizontal line is a frictionless flow and there's no air resistance.
Well, in this scenario, you can't have the floor because the floor wouldn't do anything unless the floor was in constant motion up the way. Right? So in order to have frictionless, remove the floor.
The ball appears from the left of your screen and moving towards the right.
Because if it's in contact with that, there's always going to be friction. That's what happens in reality. You have two objects of mass, touching each other, and one's in motion, there's going to be friction. which is going to slow it down. So in this example, it's flawed. What you need to do is remove the floor. No, just say frictionless, a frictionless floor, right? Because there's still going to be contact, which denotes there will be friction. So you need to remove that from the reference frame.
Right at a uniform velocity of 2 meters per second. The only two forces acting on the ball are the gravitational and the normal forces.
So we know that this gravitational thing is total lunacy, because there is no way that this floor or line can affect that ball without coming into contact with it. So if there was a gap between the two of these things here, this reference point would have no effect on that one whatsoever, unless you incorporate the normal force in their wording here, which would be this moving towards the object,
which net each other out. In this setting, will the ball ever stop moving? No, it won't. It will continue.
We'll come back to this reference frame thing. I've shown it before, but we'll come back to it. So keep that in mind.
Continue to move along the same path at the same speed unless there's another external force which acts on it. Here, as the forces are balanced, the ball will continue to move at 2 meters per second. Most people assume that if the object is moving, then there is some net force acting on it, but that's not true. An object will continue to move at uniform velocity even
Pay attention.
if the net force on it is zero. So there are two things we've learned here. First, if the object is stationary and the net force acting on it is zero, then it will continue to remain at rest. Second, if the object is moving at uniform velocity and the net force acting on it is zero, then it will continue to move at that same uniform velocity. Now, when this ball is moving at 2 meters per second and there is an external force applied from the left, what will happen? Yes, the ball will accelerate. Its velocity will change. Let's say the velocity changes to 3 meters per second after this external force is applied. After that, the ball will continue to move at 3 meters per second unless acted upon by another external force. So nobody's really seen or touched force. It can only be understood by knowing what happens to an object when force is applied to it.
So this is the thing. I'm describing force as pressure because that's what's happening. Just saying that the situation of this, we only know that we can impact it, like kicking it, which is applying the pressure, and that's what we would denote as a force.
If the body is stationary, do not assume that there is no force acting on it. And if the body is in uniform motion, do not assume that there is some net force acting on it. So what is force? A force is a push or a pull upon an object resulting from its interaction with another object.
A force is a push or a pull upon an object resulting from its interaction with another object. But again, we know there is no two options here because both these are only descriptors of go further away or bring toward. In both situations, the very same thing is required.
So when you kick the ball also exerts some force onto your leg. But as the force of your kick is stronger, the ball moves to the right. There are many more concepts we need to understand about force. Most examples we see for gravitation will relate to the Earth pulling objects towards it.
So remember what we talked about with force and what's required, and there is no such thing as pull.
Gravitation will relate to the Earth pulling objects towards it. But you should know that it's not the only force that explains gravitation. In the case of Earth and a human being, the Earth...
And this is the absurdity. So we'll look at their wee idiotic reference frame. There's nothing between the two things. There is no way that can bring that towards it without having an attachment to it, either here or some attachment above.
Earth is one object and the human being is another. Both are pulling the other towards themselves.
Pay attention again. Both are pulling the other towards themselves. Gibberish, magic, invoking of nonsense.
But why does this happen? If you do a lot of research onto what gravity really means, you may find out that gravity is not actually a force and it's just an illusion.
Yes, because there's no such thing as pull.
So for now, it's enough to know that gravitational force is just the attractive force between any two objects.
Same again with the use of words attractive, bollocks.
With non-zero mass separated by a distance. After knowing the basics, you'd probably have many questions in mind. Does the apple fall towards the earth, or does the earth move towards the apple?
And again, even in these examples, it's like giving you clues, but it's all wrapped up with the use of language and misconceptions deliberately.
If two objects always attract each other, why don't two humans get pulled towards each other? Why don't two stars collide with each other? After watching our videos based on gravitation, you will be able to answer all these questions.
No, you'll know, because your head will just be filled with other rubbish. So, I'll just utilise the name before I get to it. So, we understand that force is applying a pressure to something in order to overcome any resistance. If you apply enough pressure, you will put anything into motion. Okay? And it's going to continue in straight line uniform motion unless acted upon by some other unbalanced force or another force coming against it. So another pressure would have to be applied to it. So, let's ask the questions, right? Before I do that, I'm going to make a smoke. And again, the reason why I keep going over this is for anybody out there that's asking the questions, as I say, in order for you to understand that at the central core of this whole cosmological model, story, fantasy, they need imaginary forces in order to make it feasible, to pass it off as something tangible and real. When you only need to apply a wee bit of critical thinking, common sense, practical play, then you will understand exactly what I'm saying to you. Force, motion can be summed up as applying a pressure to something in order to make it move. As I said before, you hear them talking about gravity accelerates things towards the earth. So you'll get people talking about density in a particular medium. So let's start, right? So we're going to create a world here. What will we start with? We'll start with a square. Or we'll make it a cube, right? Get that to fuck. A rough cube, right? So right, you've got a cube, you've got another one. I'm just going to make it a square just now because I can't be fucking bothered. So if I've got a reference frame of a void, right, I've got nothing. We've got two objects. These objects have mass, right, and they all have a density to them. But let's say this one is more dense than this one. There is nothing to reference any motion or direction, right? These two objects are not going anywhere. Now, because this one is more dense than this one, does that somehow mean that this is now just going to fall or go in any direction because its density is different from this one? What if I surrounded them by some sort of containment. And what I did was I injected air in, or gas, whatever you want. Right? By just injecting air in, gas, whatever, any gases, is that now going to make this one fall in a particular direction or have any direction? No. What I would require was the containment would have to start moving, and we'll make it move in that direction. As that starts to lift in this direction, it moves. These things, the gas and the objects within it, are still not going to move until the bottom portion of this comes into contact here and starts to move them. And while that moves, what's going to happen is that the gases are going to be compressed to the base. So you're going to have a more dense layer of gas here than you're going to have up here. Because as that compresses and becomes more dense, the less dense air can now penetrate this lower portion. In the same scenario, these objects of mass, volume, density have no direction, they have no weight. Now, we can give it direction by encompassing it in some sort of reference frame, putting the reference frame into motion. The motion then comes into contact with that, and now when it comes into contact, as it moves towards, you now have an opposite reaction, a downward force, and because you have more dense here on the ground, this can't penetrate it, so you have a resistance here. And if that was moving at a uniform rate, and it came into contact with both these because of the density and the mass, right? This one is now going to register weight, which is going to be more than this one. But in that scenario, without the motion of the reference frame, the gases, the objects, the mass, the densities are not going to be relevant or have any direction or relation to each other without the reference frame being in motion. So just saying density doesn't answer any of the questions. Well, Lobo, you see it, that density does not dictate direction alone. So what is causing it to naturally go downwards? Well, downwards would be an opposite. It would be the reaction, the opposite of the reference frame. These things are no touching. This thing is suspended. As a mass, as a density. No direction. Doesn't no direction. You need this to come into contact with it, press against it, and then you're going to have a resistance factor here. So now this has the opposite, which is down. Is any of that stuff demonstrable, FPV Angel? Is there practical references for any of that? Because, again, you know, I see people talking about electrical potentials and all this stuff. So what we're talking about then, like 2 capacitor plates, as I've said before, if we're going to propose there's a level plane, right, but there's mountains and fucking, you know, valleys and fucking mountains and water, right? So what you got another plane above it, and you have some sort of transfer between the two, so it would have to be a top to bottom transfer of direction coming down equally across the whole plane. So there has to be still motion. Something has to go from one point to another point. Now I've seen it with Good Times for All, and I asked them, does it work with every known material? Or is it only with bits of polystyrene and feathers and stuff like that? Or does this type of theory and thinking incorporate all aspects? Gas, solid, liquid? How does any of that, FPV Angel, how does any of that denote direction? Something has to be moving from one point to another point. I've not checked out Walter Russell, but if you've got an understanding of it, just give me a reference. Type it in the chat that I can go to some reference and see exactly what you're talking about. Some reference that's going to show me that you can create the layers of density, you can give things weight, and you give direction by electric potential or whatever it is. Because I don't know what that means. There has to be a cause below and above. We have covered these as the halos we are seeing and recording. They are what we see as creating the pressure system. I don't even know what that means. I don't want explanations, FPV Angel. I want practical reference. I appreciate that people are asking questions and pursuing different avenues, but I'm posing these questions and I'm looking for what reality and practicality shows me. The downward thing? What downward thing? What do you mean? Right, I'll go back to it again. I'm going to do it another once on the premise that you're not just a fucking troll. Let's talk about worlds. We've got 3D space. Get fuck all in it though. Right? Let's introduce a fucking object with some mass and some density. Right? There's the object. The object's there. It's not going anywhere because it's got nothing to reference. It's not got a direction. It's got no motion to it. Right? How do I get direction? How do I get weight to the mass? Oh, well, let's see. Oh, well, we need to encase it in something. Alright, okay, there, we've encased it in something. Now what? Now we need to make the encasement move. As it moves, the base will come into contact with that, pressing against it, giving it the upward force, and now you get the opposite reaction to that, which is the downward force, and as the two are in contact we have resistance, so now we can make a metric system, a measurement of its weight. The same again, if I'm not making the reference frame move and I squirt fucking gas on there, the gas is not going to do it either. That's not getting any direction. You're not going to get density layers. If I stick gas and liquid and everything in there, it's just all going to be intermingled. Nothing's going to happen until I move the reference frame, and then as it compresses, you're going to get the liquid compressing at the bottom because it's denser than the gas. The gases are going to separate into the density layers because of the compression, the downwards force caused by the motion of the reference frame. These things are demonstrable, practical, that I can show you and you can check for yourself. So this is where I'm at right now, because I can't go anywhere else. People are talking about electric potential, magnetic forces and all this mystical jargon. Where is the practical references for any of this? And if we're talking about two planes with, electricity or whatever going, it'd have to be a downwards direction coming down the way. So what dictates that this stuff goes in that direction? And does it affect all known materials? It's like I see people just hell-bent on avoiding this. And I really don't know why. And I'm here asking the questions as an honest inquirer, inviting the conversation. And bear with me a wee second here. Why is this taking so fucking long? So based on what I've just shown you now, let's go to the globular model. Right? And try and understand why they've got to come up with all their fucking spiel, all their gibberish nonsense, right? Because in accordance with reality and what we can demonstrate, it's totally ridiculous. So okay, we're back to the same scenario again. We've got three-dimensional space. We put a fucking sphere in there, and then we spin it in a particular direction, right? How, if we've got an object, again, that's got mass, density, no direction, no weight, how does a spinny ball come into contact with that and have uniformity? It fucking well does not. Because if that was fucking spin that came into contact with that, it would just fucking skate off in whatever direction according to the spin of this thing. So what they have to do is make imaginary nonsense up, that there's some mystical thing here at the centre of this that somehow can have a sway on this thing by reaching out invisibly, magically, and winding it in, so that when it comes into contact with the surface here, we get that resistive factor where we give this weight and direction, which is down is towards the centre of my fucking circle by way of magic stuffs. And this is the thing. The flat earth is stationary. Stationary level flat earth, yeah. How did you establish that? Nothing's stationary. Everything's fucking moving. The because where clouds are coming down to Emerald Rider, as I said, if you get a containment, right, just like in the car example that I've showed, but we're going to utilise it in that direction, the gases are compressing towards the floor, where there's a band where you have the most dense air. Now clouds or whatever are only going to come so far down, and they're not going to be able to penetrate that density layer. It's not a concept either. I can demonstrate it by using the car, the helium balloon and a plumb line. I can hang a plumb line with a lead weight on it and a helium balloon side by side and a car. And I can make the car go in that direction. Now as I start to move that in that direction, the plumb line with the lead is going to move towards the back. The helium balloon is going to go forwards. Why? Because as that moves, the air is being compressed towards the back, making it more dense. The helium balloon, being less dense, now will only penetrate it and will be shifted forwards. So just turn that now, so that we've got it going in that direction. Okay? Oh look, the lead weight comes down, the helium balloon goes up, because the air is being compressed downwards. The helium balloon can't compress, can't penetrate it, and is shifted up as the reference frame is moving upwards. Anybody that's got questions and something to say about it, come and do it direct. Take the same car experiment outside, I don't know what you mean. As I say, I'm asking these questions based on what I can demonstrate to myself. But what I see is a continual avoidance of it. So containment, well, we live in air pressure. We know water's got to be contained. We have direction. There's resistance at my feet that gives me weight. So ask the questions, how do we get these things? I don't know what the container is, Emerald Rider. You're missing the point. It's not what I'm talking about. No making assertions to what the container is. We have direction. Agreed? Yes, we have down. We have weight. So we have the floor beneath us resisting us. So how does that happen? It's not about asserting what the containment is. What I've done with the containment is we have 3D space, 3-dimensional space. We've got nothing in it. So my point was if I put two objects in there, right, equal volume, different density. Right? This one is more dense than that one. It still has no direction. It still has no weight. Even if I encompass it in some sort of container, we can make it that shape, we can make it that, we can make it a fucking dome if you like. I'm just using it as an example. Even by putting it in a containment, it still doesn't make anything happen. Nothing happens. Until I make the reference frame, the containment, or whatever it is, move. I've put the link in the chat. It's always the same. How does the gas get weight? How does the gas get weight? You're saying there, Emerald Rider, that air pressure may be created by the weight of the gases above us. So, we've got gas. We'll just do the dots. We'll do the conspiracy cat thing. Fuck it. There's gas, right? How does the gas have weight? How does the gas separate into densities? If you've got a mixture of gases, helium, all the different gases, how do you separate them? The gas doesn't have any weight either. You need something coming into contact with it, pressing on it, so that it compresses. Now it will have weight, but it's not going to have weight until you get something that dictates its weight, which has to be something contacting it through motion. Right, give me a shout, Flat Earth Preacher. Oh, this is a thing. So the question becomes, what is creating the pressure system that creates motion and direction? Well, this is it. We are within it. This is why, as I say, the heliocentric model had to have the Big Bang, because it needed something to instigate the initial motion, right? But as I've pointed out, you can't have a spinny fucking ball, right, going in all different directions where it's going to come into contact with that uniformly and make it press against it, because it's spinning all over the fucking place. But they knew they still had to have an initial cause of motion. So they'll say the Big Bang. That's why you've got cartoon depictions of flying fucking elephants with a flat earth on top of it. Because we don't know. But what I'm talking about is what we can understand from being within the reference frame and how we understand motion and its laws and how they're achieved. I don't know what's out there. I don't know the prime mover, the ultimate cause. I don't know any of that. That doesn't stop me from getting to a deductive point of knowing or asserting or postulating that that's maybe what's going on. Again, don't confuse my questions and what I'm highlighting here with assertions to know the ultimate prime mover. Because that's not what I'm trying to achieve. That's the thing, Martin Allen. Again, postulating the possibility that the earth or the containment that we are within is in itself within a frictionless environment. Now it would only need one initial push that would put it into motion, and unopposed in a frictionless environment, it's going to uniformly keep moving in the same direction. Now us within it, so again, say we've got three-dimensional void space, right, and we create a wee fucking, oh, there's a wee containment, right? This is frictionless outside it. So it only needs an initial shove, a bang, an explosion, a push. And this will continually move at that same rate that it started. It's not going to speed up, it's not going to slow down because it's in a frictionless environment. Now, anything within it is going to be subject to this coming into contact with it, applying a pressure on it, which is now going to denote the downwards direction. And it's going to have resistance from the compressed materials here at the bottom as it comes into contact, and you now have uniform weight. Join me. Just click the link. Let's have the chat. Ask the questions. Well, of course, when you work on a ball, especially one that's spinning, going in all different directions, because that's no uniform. See, the thing is we don't know where we actually are and how this thing operates, but you've got people who are trying desperately to fight against any propositions like this. Now ask yourself the question why that is. Because it's no far-fetched. Because it's uniform straight line motion, which is in accordance with what we observe and test every fucking day. Remember, you've just came from a fucking belief system of spinning on an axis and wobbling and gyrating, going round the fucking sun at 65,000 miles an hour, while the sun's gone at 500,000 miles an hour, and the whole fucking thing's gone at millions of miles an hour, all fucking over the place. You've just came for that belief system. Now, you've got somebody postulating uniform motion. Oh, it's absurd. That's absurd. Can't go there. Can't think about that. No. We're going to come up with all sorts of gibberish imaginative stuffs. I'm fucking sick here. You can say whatever you want. How many people are coming here to have the discussion? How many people are coming here to put me right? What other luminaries are, Robert? How do you know the luminaries are no part of some structure? As we're moving and it rotates or does whatever it does? Because the luminaries can be part of the reference frame that we're a part of. Again, this is the thinking that people get stuck in. People are getting stuck in that the luminaries are somehow out with us in our reference frame, going back to the heliocentric model again, of spinny space balls, and all the space balls are all separated. And you're trying to think from that. Where are you getting that? Who's this? Hello?
It's Levi Foster, though.
Who?
Levi Foster.
How you doing?
How are you, mate?
No bad.
Just got a few points regards direction.
Cool.
We've got a main proven force, air pressure.
Yep.
It surrounds everything within the atmosphere.
Yep.
If you've got a dense object within the atmosphere falling, it's going to take the path of least resistance, which would be downward, because it's surrounded by pressure.
Yes, but above that, it's less dense. Why does it not move into that region? it goes in a particular direction. So if you take a lead ball, per se, and you drop it, it moves through more denser air as it goes towards the ground. There's less denser air above it. So why does it not move into the less dense region above it?
It will only move upwards if it's buoyant.
But what dictates buoyant?
If it's dense... Sorry, go on there.
But what dictates the buoyancy of it? You're still talking direction.
We're talking direction, and we're talking the density of the objects involved.
Mm-hmm.
The atmosphere is less dense than the object that is falling.
Mm-hmm.
The path of loose resistance is going to be down.
But why down? Why down?
Because that's the way pressure works.
But why does it work like that?
Oh, I have no clue.
Well,
I can only tell you what happens.
Well, this is the questions I'm asking, Levi. This is the point I'm making. So look, go back again. Right? So we've got three-dimensional space. Can you see what I'm doing here?
No, I Del, this is the second time I've ever been on a hangout, and I have no clue how to work the damn thing.
Right, so anyway, we've got three-dimensional space, and we'll just make any sort of containment. I've drew a circle, right? Now in this circle I'm putting gas, right?
Yes.
Now, that gas, it's not going to separate into density layers. It has no direction. It's got fuck all, right?
No, it doesn't separate into density layers, Del. It separates into pressure layers.
Right, but that's to do with
the pressure. It's the pressure. It's the pressure that causes motion.
Pressure, applied pressure makes motion happen. That's right.
Yes, but if an object is surrounded by pressure and it's dense, and it's a denser object than the atmosphere that's surrounding it.
But listen, in that case, what you're talking about gas, it acts equally in every direction. That's why when you blow a bubble in water, it forms a sphere.
Admittedly.
Right? So that's in every direction. That's not a particular direction of down.
No, you're factoring out the density of the object, though.
But in any case, it doesn't matter. The density in water, when you put an object in water, that pressure is equal in every direction.
And it still falls in water.
It goes down the way, although the water is applying a pressure equally all around the object. No, so why does it still go down?
Because it's denser.
That's not an answer. Just saying it's dense, look, just because it's dense does not give it direction. Because listen to what I'm saying. When it's in the water, when you go into water, right, the water is applying an equal pressure all around your body in every direction. But you still go down the way. If you let the air out of your system, you will go down.
But at the end of the day, Dale, we can only act with what happens. And what happens is things fall.
Yes, listen, Levi, I understand that. Listen, that's not what I'm pointing at. I'm asking the questions of why. And why in that direction.
So why don't you think that if an object is denser than the surrounding, than the medium that surrounds it, it will not fall?
It will not fall.
Don't forget the air's got density as well as the object.
But you're already talking, you know, what we're trying to understand is why all these things are in the positions they are in the first place. Right? So just saying density does not dictate direction.
I'm not saying density dictates direction, Dale. Right. I'm saying air pressure dictates direction.
But air pressure is not acting downwards. When you're air pressure's not acting just downwards. When you're in air like a fluid, it's acting equally all around you.
It is, Dale, but it's not acting equally underneath the object because the object is denser than the medium that surrounds it.
No, you're just not getting it, Levi. I'm sorry.
Okay, Dale, if you don't think so,
Watch again, Levi, right? So as I said at the beginning, we have two objects. I'm drawing two objects the same on my board, right? In three-dimensional space. Now, one of these objects is more dense than the other object. Okay?
That's right.
Right, so now in that situation, how are you going to dictate that this one falls downwards in relation to this one? How do you dictate that?
I'll tell you what I can dictate, Dale. I can dictate that both objects fall at the same rate, no matter what their density
They're not
is.
falling anywhere because there's nothing to reference falling. They're in three-dimensional space. So what does falling mean? Falling would suggest that it's an opposite reaction to something else that's countering it, which means something has to come into contact, pressing against them in a particular direction to denote downwards. Without that happening, you have no reference for down.
So what's happened to air pressure?
There's no air pressure unless motion happens. Because as I said to you, if I've got a three-dimensional space and I make a container and I've got air in there, right? There's no pressure. There's nothing to dictate pressure, right? Or direction. You can say that if I keep injecting it in, right, it's going to take up the space and the pressure's going to act equally upon the walls of the containment, right? But that's not going to give me the direction. What we're talking about is why there is a downwards direction. Now, the only way for me to get a downwards direction with that gas is to make the reference frame move in a particular direction. So if I make it, say, go up the way, right, there's my reference for down. If I make it go that way to the left, then anything within it, its direction for down is now here, right? Because it's relative to whatever way the reference frame is moving.
Yeah, understood. But we have a measurable force pressing down on the denser objects.
But Levi, how did all that come about is the question. I understand with air pressure. I understand these things. That's not what I'm asking. Why is there direction? Just saying air pressure, density does not dictate a direction. We have direction. Do you agree that we have a direction? Do you agree that we have down?
Yes, I do.
What dictates that?
The density of the object and the accelerating force, which is air pressure.
But how's the air pressure accelerate? So you're saying that the air's accelerating from above downwards?
Yes, that's the way air pressure works.
Well,
that's what holds us onto the
What's
Earth.
making it accelerate downwards?
Because the object is denser than the
No, what's making the air accelerate downwards?
The weight of the air causes pressure.
You're just going around in circles, Levi.
Which in turn
causes
causes acceleration.
You're just going around in circles.
Well, I don't know how else to explain it.
Because you don't understand what's been stated here. Because you're stuck somehow. Because
so you don't think air pressure will accelerate an object downwards?
I don't think air pressure would accelerate an object downwards, no.
No. So what happened to pressure creates motion?
That's applied pressure. Something pressing on something else.
Well, there is an applied pressure.
That's right.
A measurable pressure.
Yes. So what creates it?
Oh, I have no idea what creates it apart from what we're being told, which is the weight of the atmosphere.
No, what you've been told is that gravity. What you've been told, Levi, is that gravity is pulling it all towards the centre of the Earth.
And Del, I'm not talking about gravity, Del. I'm talking about density, air pressure, and buoyancy, which are proven facts.
How did you get the densities in the first place? How do you get buoyancy?
What do you mean? How do you mean? How did you get the densities?
Levi, you're just going in circles. You're just busting my chops because you've got a real lack of understanding about what I'm talking about here.
Oh, you think so, Del? So I think you're contradicting yourself.
No, I'm not contradicting myself.
You've been talking about pressure causing motion,
right? And
now you're actually denying that air pressure would cause motion.
But there has to be motion to create air pressure in the first place.
Oh, well, that's beside the point. We're talking about our object.
Levi, you're just arguing to try and be right, and you're making an absolute ass of yourself, Levi. No, you need motion in order to have air pressure in the first place. Look, Levi, I'll make it dead simple for you. Listen carefully. We've got a three-dimensional void, which means we've got direction all around us, okay? Now we make a container, right? The container's no moving.
No, we don't have direction all around us. We have pressure all around us.
Levi, you've got every direction, down, up, left, right, and every other direction from the level line. Correct or incorrect?
Correct.
Right. Now, how do you get that? What's dictating your down reference?
at this present moment in time, the weight of the air.
Why does the air get weight without any motion?
That's a question I can't answer.
Well, that's what I'm
What I
asking.
can answer-
This is the point I'm making. That's what I'm asking. How does air get direction or weight without something moving?
Right, okay, Dale. I understand what you're saying, son.
But that's what I'm asking the questions.
Well, that's really an unanswerable question, isn't it?
No, really. Right, here, Levi, here's the
Well-
thing. Listen to this, Levi, right? So I can show you an example. We're in a car and we hang a lead weight from a plumb line. And right next to it, we hang a helium balloon. Okay? Now, as we accelerate the car, the lead plumb line moves towards the back of the car and the helium balloon moves towards the front of the car. Why?
We're back to density and buoyancy.
No, yes, but the only thing the two of them are hanging parallel to each other, right? Now, the only thing that separates them is when we start to accelerate the car. Because when we accelerate the car, the air in the car compresses towards the back. So it creates a denser medium. So that the lead, being more dense, can still move through it. The helium balloon cannot. It is then pushed forward by the more dense air at the back of the car.
Because the balloon is buoyant and the lead weight is dense.
Listen carefully, Levi. Listen
That's
carefully.
a very simple. That's a very simple
listen to
interaction,
me.
Dale.
Listen to me. Look, we're in a car.
Yeah.
Like, I don't know if it's so hard for you to imagine. We're in a car that's stationary. Okay? Now,
Yes.
parallel to each other, we hang a lead weight. On the other side, we
Yes.
hang a helium balloon. Now, the two of them remain stationary
Yes.
and parallel. No moving anywhere. So they're at the same line. Okay? Then we accelerate the car and the lead weight moves to the back and the helium balloon moves forwards. The only way that happened was because we created the density layers by the motion of the car. Because until we moved it,
I understand that.
well, they didn't move anywhere until we moved the car, correct?
So once you accelerated, what did the dense object do and what did the buoyant object do?
The dense object went to the back of the car because it's more dense than the air, and the helium balloon moved forwards because the compressed air is now more dense, pushing it forward, giving it that buoyant force, as you say. But without the motion, you didn't have that separation.
Yes.
So you need the motion to create the separation.
Okay. Let me give you an example. I've got a brick in my hand. I drop it. I don't cause any motion, I just drop it. What accelerates it downwards?
The earth coming to me.
Because I'm giving it no motion.
It's no moving anywhere.
The earth coming to me.
Levi, it's no moving.
So-
I can say that it's no moving anywhere. It's the earth coming to contact it.
How is it? Okay, now what we beg to differ, there's no problem.
Right, well, you're
I
going
don't think we can excuse density buoyancy. I understand your arguments in regards the Earth coming to meet it, because
I'm no omitting. Listen carefully.
How does the atmosphere gain its density?
Listen, by motion.
I understand that.
Right? So you're agreeing with me then, you understand it, so what's the argument about?
The argument is about the way things fall in the atmosphere.
Right? And that's the question I'm saying. That's what I'm offering up here.
Yeah, but I understand, but we're at cross purposes. I understand what you're saying regards the Earth moving up, but what I'm sort of disagreeing on you with is how things fall and accelerate.
Right. So how
Air pressure accelerates things downwards. I don't give a shit whether the Earth's moving upwards. Air pressure has to.
He has no doing anything. It's no giving it acceleration.
Well, let's say at 1,000 feet, what is 14.7 pounds per square inch of pressure doing?
That's a barometer you're talking about. You're talking about a measure of weight.
That's on you. That's on all of us.
It's a way.
That's what I was taught in school.
But I'm not denying that.
Well, as I said, we're at cross purposes. What you're saying is the Earth moving upwards. I don't know whether it is. I have to admit, I don't know what how the atmosphere gains its weight. Why does it collect together? Something must be happening. But what we're at cross purposes. The way things fall in the atmosphere is an entirely different thing.
Yes. And
the way things fall in the atmosphere is because they're denser than the atmosphere, and air pressure must accelerate them downwards.
It's not that, listen, right? Because as I gave, do you want me to show you the video? I'll even make a video showing you an example in real life. We're in a car, right? The windows are sealed. We have air in the car. We hang a plumb line of lead. We hang a plumb line with a helium balloon. The two of them are parallel. So like they're parallel with the back of the seats, right? We remove the seats so they're in perfect alignment with each other. Now they don't move. They don't move in any particular direction until I accelerate the car. And when I accelerate the car, the lead one moves to the back, the helium balloon is pushed forward. So you've got an upward buoyant force because of compression due to motion.
But I've already agreed with you on that. We know that happens.
Exactly.
What you're actually saying is that air pressure does nothing.
Air pressure is not a dictator of direction.
No, the path of least resistance is the dictator of the direction.
What do you mean the path of least resistance? That's not a thing. Saying the path of least resistance is not a creator of motion or direction. It's just words.
If an object is surrounded by 14.7 pounds per square inch of pressure and it's denser than the medium it sits in, it's going to go down.
Why?
Because the air pressure from the sides and above is still giving it pressure. It's still applying pressure.
The air pressure is applied in every direction, but downwards.
But not in regards to the denser object. The denser object has to fall. The medium can't support it.
Levi, honestly.
The air pressure from above is what causes the accelerant, because that's not affected by the density of the object, but it's still applying pressure.
Aye, but it's not creating motion, and it doesn't give density layerings either. You need motion for that.
Well, we already have the motion. The object is falling.
Well, what is moving? Is it the planet that's moving, or the space above the planet that's moving? Something's moving.
I'm going to drop out. Thanks for the chat, Sean.
No worries.
I mean, if the space above the planet is moving, perhaps that's leading to other effects too. If you look at a tornado, it looks like a drain kind of circling down, like a fluid medium, of space that's, circling and swirling above the unmoving Earth, maybe.
Mm-hmm. For me, that's just about, temperature variation and cold fronts and hot fronts meeting each other and creating these things. I mean, but that's not really what I'm talking about. We have direction. So, I've gave the examples. If we start from three-dimensional space and we put an object there and we surround the object with some sort of containment, we still don't have a separation of density layers. We don't have direction. We don't have anything. We have to put it in motion in order for these things to occur.
Can you hear me though?
Aye, how you doing, mate?
Aye. I just want to pop in. I was just listening to you talking to the other guy. He didn't get it, obviously. I think I get it. I agree that the reference frame has to be moving, or
something has to be moving from one point to the other. So when we get people talking about electric potential energy and these types of things, that's what I'm saying. Okay, we've got two plates, so there must be some sort of directional flow, right? And my question in that regard is, well, is that uniform and affecting every material, every substance, every density? Does it have that capability?
Well, it has to be, right?
Well,
you can get direction from vibration, because when sound happens, it stratifies into harmonic layers. So the motion may not be a pulling or pushing motion; it may just be a vibratory motion,
But
leading
vibration,
to things,
but
stratifying.
but
there and
vibrations are pressure disturbances. When you talk and you make a noise, you're making disturbances in the air. You're fucking with the pressure. So when I speak, there's no sound coming out of my voice box. I'm making disturbances in the air that comes to your ear as waves or disturbance patterns, and you
decode that within the reference frame.
Aye.
Yeah, so we're inside of a medium that's vibrating. Now we can hear the vibration if there's air present, but even if the air isn't present, there's still vibration that can lead to stratification. You need air to hear it, but there's still vibration
But
present.
that's what I'm saying. But even in that case, you're creating, it's still the push factor, because you're having to make disturbances by using push in order to achieve that. That's what's happening when you speak.
Right.
So it's like, for me, it's very simple to understand, and people try and make it so complex and make it difficult. It's almost like there's a deep-rooted propaganda tool implanted that makes people have an aversion to even looking at this. And this is why they're coming up with all sorts of gibberish nonsense, because they're doing everything to avoid this propaganda message that you can't go here. And I'm saying, fuck you, I'm going here because that's where it's taking me.
Right.
Well, the problem is gravity needs to be a curve-making, globe-making force, but we're having lasers show flat land. So gravity is not what they told us, at least as a globe-making, orbit-making force. There has to be another force present. Otherwise, we can't account for these tests that are showing flat, level land. Gravity is not what they told us.
Well, when they talk about gravity, as I've showed, force is when something presses on something else in order to achieve motion. Gravity as a pulling force is nonsensical gibberish, because you can't have that, non-action between two objects and still achieve motion. It's total nonsense.
Well, the thing is, there has to be another force that's overarching, and the one that appears to explain the most stuff that we're seeing is electromagnetism, frequency, vibration, and from that you can get, stratification. You can get action at a distance if there is a vibratory, frequency-filled medium, say, ether or something pervading all space.
Yeah,
a vacuum, can't be nothing. It has to be something.
But that's what I'm saying. Even in a case like that, we are postulating the ether, and you're talking about frequencies. Frequency means that something goes from one point to another point. Motion. Something happens to cause motion between two points.
That's not quite true. Because when you drop a drop in the pond, you get vibration or something that looks like waves, vibration and frequency without the water moving. All that's being transferred is energy from wave crest to wave crest. With the medium squeezing, expanding, squeezing, expanding. So the movement isn't movement per se. It's just squeezing and expanding and transferring that force by squeezing and expanding.
No,
the lake doesn't move. It's just that the wave ripples through the unmoving medium.
The drip is applying a motion. It impacts the water, which then permeates outwards as a disturbance. So it's still motion being created because something moved towards something else and there was an impact. Now that impact translates to disturbance of motion.
Yes, but the lake itself isn't moving from point A to point B. It's movement within the medium of water while the medium of water stays still.
Exactly, but you still need motion within the medium. You still need motion within the medium to achieve that, which is the drop impacting the water.
Yeah, so vibration and frequency could be it's for moving or just transferring the energy to everything within the medium.
Vibrations and frequencies for me are disturbances, pressure disturbances, and whatever, ether, air, whatever it is. We can understand it through sound and radio waves and all
like
these things.
Like someone talking inside a car.
What's that?
Like someone talking inside of a car. So if you take your example with the car, if somebody talks inside the car or does something, that's a disturbance within the reference frame, but the reference frame is moving.
Exactly.
So the way I see it, I see it only two possibilities. One possibility is that the reference frame is moving, or that there's something. I don't know. I really have to
I know
think about it longer. But
the two cases that you're saying is the reference frame is either moving or the reference frame is static, but within the reference frame, you've got a top to bottom movement or transfer of something that affects things that dictates that downward direction, which is what I'm saying. Now, when people postulate these things, I'm saying, okay, now give me examples. I've seen slight examples where it works on polystyrene or pieces of paper between two capacitor plates, and you have the
Right.
transference of the electrical energy, right? But that's not shown with metal and all these different, you know, materials that we exist within. So is
yeah,
that an
I saw an
answer?
example as well, and I thought, well, what if you put an orange or something else in between the two plates? Does it
Exactly.
also go up or down? I don't know.
No, I've not seen anything. Nobody's shown me any practical reference for any of that. So until
Yeah, exactly.
we start to produce these things, then I'm at where I'm at right now, because laws of motion and these things are dictating to me that that's what it is. So I say, hang a plumb line. That's an opposite reaction to something. So what is it the opposite reaction to?
Well, the question is whether, we're moving and or the space around us is moving. If the space around us is moving, you'd expect increasing speeds as you get away from the still object. If we're moving, you'd expect decreasing speeds as you get away from the moving object, us, outward centrifugally. We appear to see stuff that's a bit more consistent with the space around us moving at best, giving us, drain-like tornadoes, drain-like, pendulums, and drain-like phenomena where something appears to be spiraling down toward us, while we're not moving.
Yeah, but that's what I'm saying. We still have that problem. There's a direction. We've got a reference of downward. Now everybody knows we have down. Now what dictates
Yeah, that can be
that?
explained with incoherent magnetism. Because coherent magnetism is when the magnet is in a concentrated area where you have a north and south pole, and you have repulsion when you have the concentrated coherent poles that are the same north-north or south-south pointing toward each other.
Mhm.
But when you take a bunch of buckyballs and make it an incoherent mass of attracting buckyballs with north-south-north all over the place in this incoherent mass of magnetism, now it can no longer repel the magnet. It's just generally attracted to it from both poles.
Yeah, but
So electromagnetism can explain this with, us being, the still center while the universe swirls around us.
so, but that, in that case, that's what I've spoken about that before. When you see the coherent magnetism and it's shown as the divergent, toroidal type field, but that only works at a central point of straight down at that specific point of the inward flow, right? But as you move away from that, it's not angled outwards. It's not straight down.
Depends on how the mass is formed. I mean, it depends on if it's a flat mass, a chunky mass that's like an iceberg. It depends on how the mass is formed, but in general, there would be a North Pole, pole, like with, magnets pointing in general toward the North Pole.
But this is the thing as well, when we bring magnetism and magnets into it. Now, where's the natural magnets, right? Because the majority of them are man-made. Now, what is that? What relevance does a magnet have to what we're talking about?
Magnetite is a naturally occurring magnetic substance, and animals have magnetic elements inside of the
Right, so
magnets.
can you hold one of these magnets above an animal and make the animal go towards it?
Water would go towards it. I don't know if they'd be pulled toward it like a tractor beam, but they might feel a general pull
But
toward
this is
it.
what I'm saying about
like
relevance, because
pull.
every single thing has a downward direction. Everything. So how does magnetism come into that then? Does magnetism, can you show and demonstrate that magnetism can create a direction for every known substance? No.
Well,
It only works with certain substances. It only works with certain substances.
Well, everything has some sort of electromagnetic nature. everything, even paper. If you cut paper into thin enough shreds, you'll paper be statically attracted to like a comb or something. It just depends on how thick it is, the forces that are flowing through it. It's a combination of things. But it appears that the main attempts in the flat earth community that I've heard of have been an attempt to absorb gravity back into electromagnetism, which frankly should have been done the moment they discovered electromagnetism, years ago. It should have been updated as more than just mass attracting mass. Electricity, is a better, or electromagnetism is a much better explanation.
And let's go back to the word attract. What does that mean? What does attract mean?
What was that?
Attract means that you're invoking that motion is being created by something that's happening between two objects. Now, under the laws of motion and what we can test and observe, you need to apply some sort of pressure, sort of force to achieve motion. You can't have two objects with nothing going on between them and the other one goes towards that. That's gibberish. So what does attract actually mean?
It goes toward it. In this case, I believe goes toward it.
That's right. It's a descriptor of direction. So it means when you bring something towards you, you'll say you've pulled it or attracted it. But the mechanisms in order to achieve the motion is applying a pressure. So how does one object apply a pressure to another object? It has to come into contact with it. Or you have to remove some factor so that you decrease the pressure here, the resistance factor, and then the object will move.
Well, I guess the question then becomes, does an object have to be in physical contact, like, touching your hands together to exert pressure on an object, or can it have action at a distance without full physical contact? Can, telepathically link to the object and cause pressure, or just, change the field that the object is in, and by, indirectly affecting the field that the object is in, exert pressure that way? We would need to see if the only thing that achieves, action and pressure is, face-to-face contact with something that we can, normally recognize, or if it's something else that doesn't need contact on some level or whatever.
Now, when you relieve the pressure, you will have the motion, but you still have these principles still apply. You cannot have this spooky action nonsense where there's nothing going on between two objects. How we understand it is if I make a releasing pressure, I can create motion. If I increase a pressure, I can create motion. So whatever magnets, and everybody invokes magnets, yet we don't even know what the fuck's going on with magnets. So they're not relevant to the discussion. And I can demonstrate a magnet as applying the very same principles. Vinnie St. Vincent's got a video up of a wheel that he's created, and he puts the magnet against it, and you can see that there's a push being applied to the wheel in order to make it spin. But we don't see a surface-to-surface contact there, but there's still some sort of pressure mediation going on there. There has to be. So does the magnet...
What is that invisible flow?
I don't know, mate, because nobody knows. It's an investigation that's still going on. It requires an investigation of its own magnetism. And you get people that are coming out with all these metaphysical concepts and theories about what they think's actually happening, and people showing you under a ferrocell and going, oh, look, this is the flux line. It's just lines. It doesn't tell me anything. So...
Well, it appears that we can get motion from everything vibrating, and different objects can probably...
But in order to create vibration...
And that's going to lead to disparity where
vibration,
the stuff is in.
Listen.
And so you're going to get of things with objects against each other, and or the medium causing action at a distance.
Vibration requires motion in the first place. You can't create a vibration without moving something.
Well, it can cause movement indirectly. If you look at the examples of the Casimir effect, where you put two plates in water and vibrate the water, it brings the plates together indirectly.
So motion's being created.
So by vibrating the medium, you can indirectly move objects toward each other.
Because you're disturbing the pressure by motion.
Yeah, you're using motion to disturb the water.
Yeah, so it would be an indirect way to move stuff together with, like in the Cavendish experiment, it could be like the mediums moving around the balls and indirectly moving them together as opposed to them having an active force of attraction where they're, being pulled toward each other for gravity. It may be indirect where the medium is just kind of vibrating the stuff together or whatever. Because we have a Schumann resonance on Earth which says that something's vibrating.
Yes.
We have, different things that show that, something's vibrating in our world.
Yeah, and that's what I'm saying. Vibration is motion. In order to make something vibrate or any of that stuff, motion has to occur. Because you're not going to have vibration without motion, because that's what vibration is. Why is it difficult to get this? I mean, my guitar strings vibrate. The only way to get them to vibrate is by applying a fucking pressure to them, moving them. So again, backing up where I'm going, the fundamental aspects of reality and experience is motion. For me, the reason we have direction is because something's moving. So is it a top-down flow of some kind, or the earth is constantly moving against me? And even in the heliocentric model, they account it, they talk
or
about
the space is moving around the Earth.
Can I finish? Even in the heliocentric model.
Well, if the space is around the Earth, sorry.
Even in the heliocentric model, they
now.
account for the upward force.
Well, I was just going to say, we can have the universe swirling around us and we'd be like an eye in the storm, where we'd be in a zone of great stillness while everything swirls around us. So it just depends on what's moving.
So if
the
swirling
medium
around us,
vibrating.
if we're in a zone of stillness, then we don't have direction either, because nothing's moving, it's still.
Everything would tend to move toward the zone of stillness in the eye of the storm, because everything's swirling around it. As you get further and further away from the zone of stillness, it would be caught up in the storm. But if you get closer to the still place, you would go toward the center of stillness, like if the Earth was in the middle. If something loses energy.
So surrounding us, then we wouldn't have direction, because surrounding us would be a swirling, centrifugal thing. That still doesn't answer the point of downward direction, resistance and weight.
Well, the centrifuge would be around us and would lead to an eye of the storm. In storms, there is a motion around the central zone where it's relatively still and calm.
Yes, it's like
it would be still calm in the center.
Pulling the plug at your bath, and the bath water goes in and it swirls round and creates a vortex pattern, right? But that vortex going downwards, you would be carried by that, and you've got that direction of down.
Yeah, that and tornadoes appear to have that behavior with some coming from the swirling zone around us down to the still zone where we are.
If it's a still zone that we're in, nothing would be happening. We wouldn't even be having an experience right now.
If the Earth is on pillars on top of a watery deep, as theories appear to say,
you wouldn't even be talking anywhere anyway. You wouldn't even be here talking to me right now if motion wasn't happening, because your heart, the blood wouldn't be being pumped around your system. You require motion within your own internal system. The heart pumping the fluid, pressing it, pushing it, around your system. Everything's moving. Everything's in motion.
Well, the thing is it moving from point A to point B versus a background backdrop, or is it just vibrating in place? We have a bit of ambiguity here, because sure, everything moves as in it can vibrate in place, but that doesn't mean that it's going from point A to point B versus some background, backdrop. If we're talking about moving from point A to point B, the Earth does not do that. It is still and stationary. But if you're saying that the Earth vibrates, sure, it can vibrate in place, but it doesn't have to translate from point A to point B. That's what I'm trying to say.
Well, then you wouldn't have direction. We've got a direction of down. So how are you going to get direction of down? If the Earth was stationary, right, this is what I'm saying, the only option you've got there, if the Earth is just a stationary plane, right, that would mean that there's got to be something above us with some sort of flow coming downwards towards the floor. Because if it's just still and stationary, then why do we have downward direction?
Most likely vibration. Vibration in place can organize space and lead to a direction.
The vibration would have to be above us, and the flow of that vibration would be coming downwards towards us.
I mean, partially. I mean, if you vibrate the medium, it organizes the medium in ways where you might have a general downward direction. It may just be frequency, electromagnetics, you know, some combination of, you know, that stuff.
But it has to flow in a particular way in order for us to have the direction of down. Because if it's just vibrating all over the place, then we don't have a reference frame of down. It would be across the way, there's down over there. We'd all be getting pushed to the side. Like being on a vibrating table.
Well, incoherent magnetism appears to offer the most demonstrable model, because you can see if the Earth is an incoherent electromagnetic mass, that stuff would just generally be attracted to it, whatever its shape.
I wonder if it's possible to replicate that situation, that example of a flow pushing instead of the floor moving up.
So then we've got other issues. What's the Earth fixed to? Is the reference frame out with the Earth something that's stationary and fixed and solid? I mean, because if the Earth's stationary in what? Is it just hanging nowhere with nothing to resist it in order to keep it still?
It appears with the Michelson-Morley experiment, they interpreted it as saying that the ether didn't exist, but there's another interpretation of the Michelson-Morley saying that the ether does exist, number one. Space does have some sort of solidity versus which you have an absolute reference frame to measure motion, but unfortunately they didn't get enough ether drift to prove that the Earth was moving. They needed 30 kilometers per second. They got more like 8. So rather than junk Copernicanism, they junked the ether and cut it into bits with a quantum theory. So they try to test the motion of the Earth from like A to B.
So you'd have to be
the experiments are found wanting.
You'd have to be postulating that the ether has a directional flow. If that's the thing that you're going to invoke that gives us our direction, the ether would have to have a directional flow of top to bottom. The fact of the matter is that we have direction, we have weight, and we have density layering. Now, as far as I'm concerned, the only way that I can see that happening is by motion. Right? Now, as I say, I can shake up an oil chamber with different densities of liquid in it. Right? Then I can spin in circles, accelerating, and those density layers will separate. Then let me finish. Then I can stop and I can put it on a table, and the fucking very same thing will happen. So what's causing that then? Because they're all separating into their density layers. Now something's dictating that.
Well, the thing is, if you have motion in a medium, you're going to have a Doppler effect, where you're going to feel pushed as you're moving against the medium, and you're going to have a bit of a less push at the back.
I'm talking about
the medium flowing over you. So you still have
I'm talking about a sealed chamber.
Because if the Earth is, say, going through space and going through some sort of a medium, you'd expect a Doppler effect where the medium would be pushing against the Earth.
But listen, in that scenario, I can make a sealed jar. It's not an opened system where there's air pressure being applied or anything like that. It's a sealed jar. And I can spin it round in a circle, and those oils or liquids will separate into the density layers. Then I can place it on a table, and the very same thing will happen. So
Yeah,
motion.
we'd have to spin in a contained system, so you'd have to say what's containing the Earth, other than a firmamental barrier, which is kind of back in flat Earth land. You know, the only paradigm that can deal with firmamental solid containment is something flat.
That's what I'm saying. What I'm showing here is that we can use examples, practical references. That does not mean I'm jumping to state I know what the containment is, or where we are positioned, what medium we're in, or what we're moving through, or any of that stuff. I'm starting from an understanding of my reality directly and what things are showing me through practical reference. And I'm asking these questions.
I wish I had the answer.
Well, this is it, mate. But we're not going to get them unless we ask the questions and we further the investigation. But what we can admit is nonsense drivel of pulley forces and all this gibberish that the heliocentric model wants to throw at us. But as I say,
Or a turtle.
it's so much resistance from supposed skeptics and truth seekers whenever you bring this subject up. Now I'm asking that question. Why do we think that is? Because I'm not getting any coherent rebuttals to what it is I'm offering.
Well, I think it's because they went from something like gravity and they probably couldn't handle that there was nothing else to replace it. So they just come up with other stuff.
Aye, and they'll just say density. Oh, the denser object falls through the less dense, and it's like,
Yeah, but no density without motion.
aye. So why is it happening? Why is it still moving towards the Earth? But people don't want to go there.
Because it's scary, probably.
And what the heliocentrics are offering up is a sophist nonsense gibberish of a force pulling stuff. And even when I showed the video, they talk about both objects, the spaceman and the Earth's moving towards the spaceman, and the spaceman's moving towards the Earth. So they're showing you that, and they talk about the upward force.
Well, gravity is a force that can do everything. It has its own fuel. What generates gravity mass. What generates mass or accumulates mass? It's gravity. That's a circular, godlike force.
Yep.
So it's going to be very hard to compete against that because it's a universal force that can make a cosmology. It can make everything that they need, for their theories and their religion and everything.
Well, see,
they're not going to give that up.
It's easy to break it apart. Demonstrate a pulling force. End of story. Done. Right there and then. Doesn't exist. It's gibberish nonsense. Mathematical sophistry. End of story. See, they require it because they need a god of the gaps. They need mystical, magical gibberish in order to push forward a nonsensical, idiotic concept. You're nodding there, so you obviously see it. It's simple.
Yeah. Yeah, to me it is, yeah. It's gravity is just it's their go-to thing. As soon as they don't know something or where the lie is not yet developed, they say, "Oh, gravity."
We can just invoke it for anything they like because it's a concept. It's not a thing. It doesn't achieve anything, But because people are enamoured by these buzzwords and these religious mantras, they just offer them up continually. When you go, right, let's get to the mechanisms of this apparent force. How does it operate? How does it function? Demonstrate it for me. Show me a pulling force. Doesn't exist. Game over.
Yeah, or they just say, "Oh, I don't know," but they still believe in it, and it's not like, "Oh, you just showed me that it's bollocks, so out with it." No, it's like, no, you showed me it's bollocks, but I'm gonna believe in it anyway.
It's because it's the core, it's the hub, it's the glue that holds their whole nonsense together.
Right, the glue, yeah.
So as I say, that's where I'm at, and that's where my contemplations have went, and that's as far as I can reach right now. Until, as I say, I'm not set in stone with any of it. These people that are talking about electric potentials and magnetics and this, that, and the other, they start demonstrating it then. Not just examples of bits of polystyrene. This, that, and, you know, that's not good enough, because we don't live in polystyrene world.
No, but I was thinking, like you showed a video of a guy with a he apparently showed the flow of magnetic stuff.
Eric Laithwaite, yeah.
Yeah, maybe that guy. But I was thinking, what if that needs motion as well? What if that flow is there because there's motion?
Yeah, or
You know what I mean?
Or is it just creating like a fold, some sort of disturbance in maybe an ether or whatever? It creates a pressure region. It disturbs the pressure in some way. So like, like, I don't know if you can see me right now, right? So Eric Laithwaite showed a racket.
No, I can't see that. I can only see your
Eric Laithwaite showed a cog, right? So we've got a cog system, right? I'll just draw it simply, right? So imagine you've got a cog. I know you can't see it. Then he's got a rack underneath it. Now, when you push the rack, it comes into contact with this, pushing it in this direction. This now comes down, the next one pushes against it, and you get that continual motion of one surface pressing on another surface. Then he removes the rack and he replaces it with a row of magnets. So there's no surface contact, but the very same thing happens. As he pushes the rack, the thing moves in the same direction. So it's almost like the magnets are creating some sort of fold or pressure disturbance or increasing pressure surrounding that cog in order to achieve the motion. So, I mean, even in the examples, it's just backing up everything that I'm pointing towards.
Right. But the magnets, they were moving, right?
He had to move the rack with the magnets on it. So the magnets are static. Right. And then he moves the rack, and the rack, as it moves past the cog moves the same direction as when he had the analog rack that actually surface contacted the cog.
Interesting.
Yeah, very interesting. I'm just saying it's interesting and requires proper investigation. You know, but you've got these people and gurus running about the place asserting that they know what's going on. I'm like, well, demonstrate it then. Well, I'm yet to see it.
Well, yeah, it's very interesting to me that if this reference frame is moving, then I'm immediately thinking, where is it in moving? Because it has to be, right? If it's moving, it has to be.
Aye, there's something out with us. Maybe this is where they get the notion of a frictionless, vacuous environment. Maybe that's what we're moving through, an infinite three-dimensional space.
Yeah, who knows?
Well, they can invoke infinite spaces. So, if I want to talk about it, then we can invoke that as a thought experiment. I'm not certain that that's the case. As I say, it's an investigation. We don't know what surrounds us. We don't know the parameters, where it ends, where it begins, what's the medium that we're within, what's out with the structure. I mean, none of that's been answered. I'm talking purely from what's been offered to us right now and what we can use as examples to demonstrate. Because that's my whole premise. If we're discussing things with each other, we need to have some sort of practical references, or we're just talking about thoughts and concepts that are no use to me, because I'm not interested in any of that. I'm a man.
Yeah, I think it comes down to exploration.
Well, the thing is, you need to have a paradigm and a philosophy to guide your exploration. Otherwise, you won't know what to do with observations when you get them. It appears that vibration can lead to a layering and a gradient.
Sorry, see that?
So you don't need to be moving through space at all. You just need to have vibratory motion, and you can be still and stationary.
But you're vibrating right now. You're no stationary. You're vibrating because motion's happening within your own system. I don't know why you keep getting back to this.
You have to go from point A to point B, or are you saying that you can just vibrate in place? What are you saying?
There's motion happening internally with you. You're not moving about in the reference frame right now, but there's motion within you.
Saying that vibration is good enough for the movement, or are you saying that you're moving from point A to point B versus a backdrop in space?
Your heart is pumping right now, correct?
I am still in stationary, but my chest is moving up and down while I'm breathing.
You're no stationary then. There's motion happening.
Yeah. But are you saying that we're going from A to B versus a backdrop?
No, internally, within your internal system, things are moving from point A to point B. Motion. It's a vibration. There's motion. There has to be something going from one point to another. Or you would be dead.
But you can vibrate in place and not move and be stationary.
No, because vibration dictates motion. So by saying something's vibrating means it's no stationary. Stationary means nothing moving, static, no motion, dead.
But I'm moving right now, I'm stationary, but my chest is breathing up and down.
Yep.
So in the sense of
you're stationary within the reference frame.
Well, in the context of moving from point A to point B, I'm still in stationary.
But internally, the blood's moving, your heart's pumping, there's motion happening, your lungs are expanding.
There's motion, so the reference frame has to be fucking moving, as far as I see it.
Something's moving, mate. This mantra, stationary, static, it's gibberish.
Yeah, I'm wondering, because, you know, if they claim it's stationary, then what is holding it, or like something? Because because there has to be motion. If it's stationary, then
what's it connected to? What's it connected to?
Yeah, exactly. What is it?
What's keeping it stationary? And if it is stationary within the reference frame, us inside this apparent stationary thing, although we don't know what's keeping it stationary, there has to be motion happening internally. So that can only be a top to bottom type of motion. So something's flowing from above us to the floor.
Yeah, that doesn't make any sense to me.
That doesn't make any sense to me either, mate.
I go with the Hebrew cosmology, flat covered by a dome on pillars on top of a watery deep. So that appears to be the most coherent one, and most ancient cosmologies appear to point to that.
So it's appeal to consensus.
Well, if they had the truth, it would tend to come, from everybody having the truth by consensus at first, and then variations happening later.
How did they
All of
establish?
these cultures throughout the world, Navajo, Aztec, Mayan, Indian.
How did they establish it?
But a shitload of people these days believe it's a fucking globe, and it doesn't make it true.
Well, that's what I'm saying. And all that. Listen. If you're what you've just suggested is that these ancients, right, that postulated this, they somehow managed to get outside of this reference frame and assess outside of it and see where it was attached to. Is that what you think actually happened?
Basically, it looks like the Catholic Jesuits tried to come up with their own cosmology.
Answer my question.
Based on Kabbalism, Greek mystery school.
But listen,
subjective interpretations.
Yeah, but
you've just a very consistent interpretation, though, given the fact that the Jesuits were the ones pushing this stuff.
Well, you've just asserted, right, or suggested that the ancients had some sort of truth, right? So in that statement, what you're suggesting is that this fixed, immovable earth, right, and that the reference frame that we exist within, these ancients managed to remove themselves from that reference frame and assess what was underneath us and what it was attached to and all this stuff, and that's what you believe.
No, my assertion is that they had revelation from a superior source that built it like God.
All right, okay. So it's faith. We're into imagination land. That's fine. That's up to you. You can have faith and belief and all that stuff if you like, but it's not good enough for me.
Well, aren't you having faith that your limited human senses are sufficient to explore the whole world? I mean, that's just as faith-based, isn't it?
No, because I'm within the
What
world.
if you're wrong?
What
if you need revelation?
What I would suggest is that I am within this reference frame. I am part of the effect. Now, for me, philosophically, it's an impossibility for me to remove myself from the effect to see the thing as a whole, because I am part of the effect, and there in turn lies the problem. Can we ever get to the real root of it? Because what is the prime mover? Because there has to be something that put this whole thing into motion. And if
Well, it sounds you need an outside authority that is superior to appeal to. God kind of takes care of that, especially if he made the thing.
Well, it's all right for you to suggest that, but to start suggest you know what that is preposterous as far as I'm concerned.
Well, if you can't know it, then how can you not know it? You know, I mean, without faith, you're eventually going to need to act, which means that you're going to need to do, something. You're going to need to act as if he exists or that he does not exist. So eventually that's going to require faith. No, we can't have complete information. That'll be revealed later. Faith's
only required when I take one step from an intellectual understanding of saying that there's a prime mover. Now, I can stop there. Now, where I would require faith is when I start trying to imagine or suggest what that prime mover is. Then I would require faith in my postulation if that's what I chose. But I'm not one of these people. I don't require to have a belief in what that is or a faith in it because I'm not opting for a particular choice. So I don't need faith. I can pursue internally within the reference frame and see how far I can get, without any preconceived notion of what I'm going to find or what I expect to be there. I don't need that.
Well, unless your senses can encapsulate the whole of reality, you're going to need faith to get to the places in reality.
I never said that. You're straw manning me. You're saying asserting that that's what I'm stating. I'm not stating that. Listen clearly. I am within the reference frame. I have this faculty. I can take it as far as I can within the reference frame and find out as much as I can. I don't need
then
faith.
You're going to have limited knowledge that's never going to be complete. It's just going to be whatever your limited senses can encapsulate.
Well, if I come up against limitation, then I come up against limitation. That's where it ends. I don't need to start invoking beliefs and imagination. I don't require that. I'm not insecure. I don't need certainty that desperately. Anyhow, cheers for the discussion, guys. I'm going to get off. All right. Cheers, Nellis.
All right. Cheers.
Cheers, Levi and or Eve. See you later.
All right.
So, I'm going to give you the chat box 5 minutes to have your say as well. I'm not away yet. Premature bye-byes. 5 minutes. I never had any attention on the chat box, so I want to give you people the opportunity. That's my new motto. Nice one, Joe. Something comes to exist, doesn't that dictate what's up and down? No. Okay. So in order for something to come to exist as we know it, we need three-dimensional space. Study. So three-dimensional space doesn't have any parameters, right? There, something came to exist. A ball. How does that ball now have up and down in direction? Just because it came to exist. It needs to be in motion. So if I put it in motion that way, right? Oh, it's in motion in that direction. So it's opposite of down is in that direction. And I can draw a line between them. And now I've got sideways, I've got that direction, and I've got that direction, and every other possible. But without the motion, I don't have any of that. No, it certainly does not, Robert. That's not the thing. But you know, I've got questions. So you know fine well, you know, for me, the way in which objects fall is nothing to do with it. But we have direction, and I'm curious about that when I'm asking that question because that's where my attention is. But it's not going to bring us any closer to exploring the parameters of where we are, of course. What's the prime mover exactly? That's it, perfection. That's the whole thing. But we are observers. Even if I made a man, you know, as Sidney was asking about an object or whatever, if something appears, then it surely has direction. Okay, well, let's put a sentient being in there. We'll put a sentient stick man. Sentient stick man. Sentient stick man could just as well be like that. Sentient stick man doesn't have any direction either. Sentient stick man has to have motion. Sentient stick man needs to have something applying a pressure to put him in motion. So sentient stick man now has the opposite of that. It's down. That's it, Robert. Exactly, Dill, who's asking exactly. But it's like a mental block because of the use of fucking propaganda. I'm convinced of it. There's a pointed out force. Something has to press on something else. Gravity, purely nonsense, gibberish. Cause and effect, exactly. I am because we are one love. We have down. What's the cause? Down would be the opposite of the counter, which would be something coming to meet us. Oh, I'm not allowed to see that. I'm not allowed. Why? Reasons. What are those reasons? Don't have any. Tech Talks dielectric magnetism makes sense. Show me dielectric magnetism affecting all substances. Show me separating stuff into density layers and giving direction and affecting all known materials. Because everything is subject to this. not just cherry-picked pieces of material. Right. No doubt I shall be back at this, because we'll get the usual fucking gimps waiting until the stream is over, waiting until comments come in, and then fucking spamming the comment section. So I'm going to keep visiting this, because it's not going to go away just because people don't like it. So I'm not here to please you. I'm here to fucking investigate and ask questions. And if this is where the investigation goes, so be it. People keep assuming the containment is dome shaped, I know. Ask them why. Tell you why. It's because when they look out into the world, it looks as if they're in a dome. If you've got two fucking flat parallels like that and you're in between them, it's going to look as if you're in a dome, although it's fucking a perfectly flat roof. Go into a massive warehouse and observe. If you don't have containment, FPV Angel, then what you're saying that you're assuming containment, right? Well, that would mean then that the air system is infinite, and that there is no other medium out with. If we're in some other medium, there has to be some sort of containment. But if you don't, what you're invoking is that the air in the space is infinite, which is going to bring about a whole load of other issues and problems. See, people are just looking for things to cause problems when there's nothing there to cause a problem with. No, if it's a non-resistant space, there's nothing to oppose it. You know, motion will remain uniform unless acted upon by another unbalanced force. I can demonstrate that to you. If it's a frictionless environment, there's nothing to oppose that motion. You don't have to keep power in it. Once it's moving, there's nothing to resist, nothing to stop it from moving. It's just going to keep moving indefinitely until it comes up against some other resistance. Exactly, FPV Angel. That's always been my message with Require exploration. If it's non-contained in some way, you're invoking the opposite, that it's somehow infinite. And how would that work? That would mean it's infinite down the way, across the way, up the way, and every other direction. Good Las Vegas Elite, because that's where it falls short. Ask them. Pooling forces, what's the physical interaction? Magic. Abracadabra. Right. Cheers, people. Again, I'll be back visiting this, no doubt. And so we should. Keep questioning, keep playing with it in your mind, go back over it, have a listen again, formulate your questions, formulate your points, bring them. Let's have a look at it. I've got nothing to hide. I'm no gatekeeping anything. I'm asking the questions. It's these other people who are avoiding it, telling you can't go there, and using ad hominems and hand-waving dismissals That's not going to help the progress. So pay no attention to any of that, because it's not useful. See you shortly.